Okay, so for my numeracy lesson plan, basically what I picked was the outside diameter micrometer, and with that, we're going to measure a crankshaft journal as the final exercise. I picked the outside diameter micrometer because, as a technician, that tool I use a lot of the times to, like, if I'm measuring brake rotors or any wearing components, I can go sit with the customer and actually show him with the manufacturer's spec. Listen, this is the spec for this. It could be your left front rotors measuring this, your right front rotors measuring this, and so on and so forth. So the customer has um, a better understanding of what's going on. He trusts me because now I got numbers to back my facts. I'm not just saying you need rotors because they're worn. Then like then that leaves the customer to say, well, is he just trying to change parts, or his mind can wander. This way I got concrete information. This is what I got. That's why you need to change it. So for the students, the learning target is to apply appropriate math when using a micrometer, correctly interpret the illustration. So that goes with the exercise I give of how to read the micrometer. Use the basic tools to measure engine components. That's the micrometer. And then there's also all the tools that involve the hand tools that they use to take apart that engine that they're going to measure at the end, which is the crank. The last component you take out of the engine is the crankshaft. So the use of basic tools, perform appropriate measurements with the micrometer, and demonstrate a good housekeeping, which is always important in every trade, to keep things clean and to have a good order of all your stuff. It allows people that are watching you to say, this guy knows what he's doing, he's a pro, and it allows you to rebuild or put your components back together way easier than if you're looking through a pile of parts. There's bolts everywhere, there's no order, it's a mess. So that's always a really important thing. And there's also how to use a service manual to find the specs. And in there, I don't know where my number 7 went, but there's supposed to be health and safety, which there's always very strong health and safety in everything we do in a shop, in a garage, in the classroom, always thinking about health and safety. So my first step would be to load this on a smart board, pass a bunch of micrometers around to the students so they can actually touch them and see that when you turn the ratchet, the thimble moves in, the thimble turns, the spindle goes towards the anvil, and they get to play with it, touch it, look at it. I would explain that this is an inch micrometer, that it comes in many different sizes. A lot of them have just a different anvil, so that the micrometer would be much bigger, and you replace the anvil for different size, 2-inch, 3-inch, 4-inch, whatever the case is. And we just go through the parts. So it's important to use the ratchet to pull it in and not torque on this big thimble part. To lock your micrometer so you can physically take it off and read it, and that the spindle and anvil are the component that actually gives you your measurement here, and that this thing is actually, you can calibrate it if somebody either torqued it too much, or sometimes just temperature changes and stuff. If you keep this bottomed out, temperature change might tweak the bottom of the micrometer. My next step would be to load my micrometer simulator. So right now I just have it at a simple spot where I can actually tell the students how to read this thing. Um, so we would just start talking about the how this is your the main scale is on the barrel part of the micrometer, and that this thimble part is another. There's three scales to measure: the one, the two on the thimble, and then the vernier scale up here if you're between lines. So it just gives you to 10,000ths of an inch. So basically what we would say is we got every graduated line, so we'd say here, I'd write it on the board, 0.025 here, they're 25,000ths of an inch. So 0.025, 0.050, 0.075. So what I would say would basically be 25 thousandths, 50, then you got 75, 1, 100, 125, 150, 175, 200, and so on. So if you look at where this is, you're looking at your main bar reading. Everything aligns here. We've got a 0 here. So if we were to write this down, like I would do on the board, we'd have the proper math for that would look something like this. I wish I had better. So you got your 2 at the top, which you put down your 200. You can't really see that. And then your 75,000 down here. So when you put a little addition mark here, you get 0.275. So 275 thousandths of an inch. So I would go through the class, and basically, once I explained this, I could then explain this section here, where I'll add a couple of marks here. If you end up between two lines, just like here, so what's happening here is you're not on the 0. The 0 is now past your reading line, and the 1 would be up here. Well, that doesn't work. That's when you have to go up to your vernier scale, and you always go to the bottom line. So that's why it stays 0.275. You're between the lines. You go up on your vernier scale, and now you got to match lines up here. So none of the lines are matching up till you get to the 7 here. Hence why they have 0.2757. So basically that just breaks down, this scale breaks down when you end up between two lines, which is that 10,000ths of an inch of a difference. So we would go through the micrometer slowly. Then basically what I would do is just play it, if it wants to play. There you go. And stop it at random places, and then ask every student to answer one of the readings. I would obviously hide this either with my hand or a piece of paper. After we went through this and all the kids grasp or have a good idea of what's going on here, I would then pass the first exercise sheet, which is this one. They get to answer. We'll do this in pairs. They get to answer each question, and then we'll go over every micrometer reading, and also add my answer sheet here, so I don't have to break every single one down. We'll go through the groups, and they can answer the micrometer questions. So after I know that they understand and they can read the micrometer, I got the exercise sheet for exercise 2 for the actual journal measurements. So this one we would get up, go to the shop, out of the classroom into the shop. That's how I was set up where I work. And wear safety glasses or steel toe boots. The kids wear coveralls. If they want gloves on their hands, they don't want to play with the oil, they can wear gloves. So then we'll go through this. They'll be handed a service manual, which they have to look up specs for their crankshaft that they have for their motor. The first thing that we're going to do here is inspect the crankshaft to see if it's good or not. So in a dealership situation or a garage, you would inspect the crank bearings. You would itself, if it's scored, if it shows that a lot of times it'll show you like the signs of wear on your bearing already. You'll have a good idea. I'll go check. These bearings look pretty good, but this one looks bad. I'll go check this one right away instead of measuring every single one. So just so they have a concept that they don't have to go through everything, there's shortcuts here. We'll look at that. If the crankshaft is scored itself, it's no good. Anyway, so then I'll go through their specs. The stuff in red is to highlight what to check before even measuring. After we put our crankshaft in V blocks, the students will have to actually measure the journals. So here it shows you different points to check on your journal. So you don't just check like this on both, and you have to check both sides, both edges. You don't just check both edges like this. This will show you if this part is tapered or worn uneven. But you also have to check if it's out around or oval. So what we're doing is checking different 180 or 90 degreeing our micrometer to check the different part of the journal. So we're checking like this, then like this, and that'll give us what's going on with our crankshaft journals. So basically they'll write their specs down at the bottom and put down their measurements for the journals, for each journals, and that should be it. They should have a good understanding how to measure after that, because there's lots of journals. They'll be in groups of 3. That's what I was doing, groups of 3 on an engine, and they get to go and measure all their stuff, and I circulated around just to make sure that they actually knew what they were doing and grasping properly how it worked, the proper use of the tool, the proper math to reading the tool. And yeah, so after that, they can measure throughout the year. We'd use it to measure different things, different components. They'll use it as they're assembling the engine. They'll use it as on other components like the camshaft. They'll use it on brakes, wear items. Through this picture was taken from GM there, Canada. So they have very clear indications of what they want, and they show you what they want. So I would definitely show them also that I guess my service manual that I used to, how detailed it is online, so they have a better idea of real life dealerships. This is all the steps. We'd also go through that. So it would probably take 2 periods for sure to do this. And maybe more, but I'm pretty sure in two they'd be good. So that's all I got. So I got my lesson plan with my steps. I got the parts of the micrometer, of the inch micrometer. I got the simulator that I'll run through and make sure everybody knows. I got my exercise sitting at the desk in pair, and then I have actual shop measuring. So that'd be it. I hope it's good. That's it. Thank you.